Picture a night sky, clear and brilliant with stars. The kind of night where the cosmos feels within reach, and the universe seems to whisper its secrets to those who dare to listen. The stars twinkle like diamonds scattered across a velvet canvas, each one a distant sun, a beacon of light in the vast darkness. Now imagine this, a sudden blinding flash, brighter than the sun. A light so intense it turns night into day for a brief, shocking moment. It's as if the heavens themselves have been torn asunder, revealing a raw, unfiltered power that leaves you breathless and disoriented. This wasn't a supernova, a dying star's last gasp. It wasn't the natural end of a celestial giant collapsing under its own gravity and exploding in a final glorious burst of energy. No, this was something entirely different, something man-made. This was humanity flexing its nuclear muscles in the vastness of space, a demonstration of our technological prowess and our capacity for destruction. It was a bold, audacious act, one that would have far-reaching consequences for our understanding of both science and our place in the universe. On July 9th, 1962, the United States detonated a nuclear bomb high above the Earth. This was no ordinary test. It was an experiment on a grand scale, conducted in the upper reaches of our atmosphere. The bomb, codenamed Starfish Prime, was part of a series of high-altitude nuclear tests designed to study the effects of nuclear explosions in space. This was Starfish Prime, an event that painted the night sky with an eerie, artificial aurora. The explosion released a burst of energy that interacted with the Earth's magnetic field, creating a dazzling display of red and green lights that danced across the sky. It was a sight both beautiful and terrifying, a reminder of the power we wield and the delicate balance of our planet's natural systems. People thousands of miles away in Hawaii watched in awe and fear. Streetlights went out, radio communications went haywire. The electromagnetic pulse generated by the explosion disrupted electronic systems, causing widespread blackouts and communication failures. It was a stark demonstration of the vulnerability of our modern infrastructure to such powerful forces. The sky shimmered with an otherworldly glow. The auroras created by the explosion were unlike anything seen before, a surreal blend of colors that seemed to pulse and shift with a life of their own. It was a spectacle that left an indelible mark on the memories of those who witnessed it. Little did they know, this spectacular display was just the tip of the iceberg. The true impact of Starfish Prime would only become apparent in the years to come as scientists studied the data and grappled with the implications of what they had unleashed. Starfish Prime was a wake-up call, a stark reminder of our power to affect the cosmos. It showed us that our actions, even those taken far above the Earth's surface, could have profound and far-reaching consequences. It was a moment of reckoning, a chance to reflect on the responsibilities that come with such immense power. It revealed the fragility of our technological civilization in the face of forces we were just beginning to understand. The experiment underscored the need for caution and foresight as we continue to explore and manipulate the natural world. It was a lesson in humility, a reminder that we are but a small part of a vast and complex universe, and that our actions can have unintended and far-reaching effects. Starfish Prime wasn't an isolated event. It was a pivotal part of a grander scheme, a series of high-altitude nuclear tests known as Operation Fishbowl. The Cold War was at its zenith, a time of intense rivalry and suspicion. The US and the Soviet Union, locked in a perilous nuclear standoff, were desperate to push the boundaries of their arsenals. They sought to uncover how nuclear weapons would behave in the vastness of space and their potential impact on enemy satellites and communication systems. Operation Fishbowl featured several detonations, each meticulously designed to probe different facets of nuclear explosions at high altitudes. These tests were cloaked in secrecy, fueled by an atmosphere of fear and paranoia. Yet their effects were anything but hidden. The world watched with bated breath, mesmerized by the spectacle of the explosions and haunted by the terrifying implications of this new kind of warfare. The Starfish Prime detonation, 250 miles above the Earth, unleashed a ferocious electromagnetic pulse, or EMP. This event was part of a series of high-altitude nuclear tests conducted by the United States in 1962 during the height of the Cold War. The goal was to understand the effects of nuclear explosions in space, but the results were far more dramatic and intense than anyone had imagined. This invisible surge of energy raced outwards at the speed of light, wreaking havoc on electrical systems across a vast area. The EMP waves spread like wildfire, causing immediate and widespread chaos to electronic devices and infrastructure. It was a stark reminder of the terrifying power of nuclear weapons, not just through their explosive force, but through their ability to cripple technology in an instant. An EMP is like a sudden, intense electrical storm, but on a colossal scale. While a typical electrical storm might cause localized power outages or damage to individual devices, an EMP can devastate entire regions, rendering electronic systems useless in a heartbeat. The comparison helps to illustrate the sheer scale and ferocity of the phenomenon. It's created when a nuclear explosion interacts with the Earth's magnetic field and atmosphere. This interaction is a complex dance, involving the rapid acceleration of charged particles, which then generate a powerful burst of electromagnetic radiation. The Earth's magnetic field plays a crucial role in shaping the spread and intensity of the EMP, turning it into a storm of unparalleled magnitude. This interaction generates a burst of electromagnetic radiation that can fry electronics, causing widespread blackouts and communication failures. The radiation can induce currents in electrical circuits, leading to short circuits, fires, and the complete failure of electronic systems. The impact on modern society, which relies heavily on technology, would be nothing short of catastrophic. The EMP from Starfish Prime was far stronger than anyone had anticipated. Scientists and military officials were stunned by the extent of the damage. The test provided valuable data, but also raised serious concerns about the potential use of EMPs as a weapon of mass disruption. It knocked out streetlights in Hawaii, some 900 miles away from the detonation site. The sudden plunge into darkness in such a distant location highlighted the far-reaching and terrifying effects of the EMP. People were left in awe and fear of the invisible force that had plunged their streets into darkness. It disrupted radio communications across the Pacific. Ships and aircraft experienced sudden and unexplained communication blackouts, leading to confusion and concern. The disruption of radio signals underscored the vulnerability of communication networks to the stormy wrath of EMPs. It even damaged several satellites in low Earth orbit, showcasing the vulnerability of our fledgling space infrastructure. The damage to these early satellites demonstrated that even space-based technology was not immune to the effects of an EMP. This realization prompted further research into protecting satellites and other critical infrastructure from such stormy threats. To truly grasp the impact of Starfish Prime, we must journey into the fascinating realms of EMPs and the Earth's magnetic field. The Starfish Prime test, a high-altitude nuclear experiment conducted by the United States on July 9, 1962, unveiled profound insights into electromagnetic pulses, EMPs, and their far-reaching effects on our planet. Imagine the Earth as a colossal magnet enveloped by an invisible shield, the magnetosphere. This magnetosphere is a vast region dominated by Earth's magnetic field, deflecting the relentless solar wind, a stream of charged particles hurled from the sun. This protective shield guards us from the ceaseless bombardment of solar wind. When these particles clash with the magnetosphere, they can create mesmerizing displays like the Northern Lights or auroras illuminating the skies near the polar regions. A nuclear explosion in space unleashes an immense burst of energy, including gamma rays. These gamma rays, a potent form of electromagnetic radiation, carry staggering amounts of energy that can dramatically alter the Earth's atmosphere and magnetic field. As these gamma rays collide with the Earth's atmosphere, they strip electrons from atoms, generating a colossal electrical current. This phenomenon, known as ionization, can trigger the formation of an electromagnetic pulse, or EMP. This current then produces a powerful electromagnetic pulse that radiates outward, disrupting anything dependent on electricity. The EMP can cause widespread electrical chaos, impacting power grids, communication networks, and electronic devices. Starfish Prime forged an artificial radiation belt around Earth. This belt, teeming with high-energy particles, was ensnared by the Earth's magnetic field, creating a new, albeit temporary, layer of radiation encircling our planet. This belt of high-energy particles lingered for years, disrupting satellite operations and posing a threat to astronauts. The radiation belt caused malfunctions in several satellites, deepening our understanding of the vulnerabilities of space-based technology. This event underscored the intricate interconnectedness of Earth and space, revealing how human actions can ripple far beyond our planet's surface. The Starfish Prime test was a stark reminder of the delicate balance between our technological advancements and the natural forces that shape our world. It highlighted the critical need to comprehend and respect these unseen forces, as they hold the power to profoundly and enduringly impact our civilization and the environment we rely on.